Section 8.6 really is a review of and an application, I guess, of all of our properties that we've discussed regarding the special types of quadrilaterals here that we've looked at. And so the first thing I'm going to do is I'm going to discuss briefly this this hierarchy, okay, or this flow chart sort of thing that we have regarding quadrilaterals. And so this will just summarize everything that we've discussed in the chapter so far, and then obviously we'll get into some more specific examples that you have to be familiar with in section 8.6. So first of all, the most basic type of four-sided figure we've talked about is a quadrilateral, okay? And I know I didn't give myself much room on here, and you don't have much room on yours either to write, so kind of bear with me here. I'm going to do the best I can to keep this legible. So the definition of a quadrilateral is very simple: four-sided polygon. Okay, and again, I know my writing isn't the best, so bear with me. If you have to go back and rewatch just to kind of hear what I'm saying, then do so. So underneath the umbrella of quadrilateral, the first one we talked about is the quadrilateral that has two sets of parallel sides. Okay, namely, if you have two sets of parallel sides, you are a parallelogram. Okay, and underneath parallelogram, we've talked about 5 unique properties. Okay, the first, and these are in no particular order, okay, but we know opposite sides are parallel. We also know opposite sides are congruent. Okay, the third thing we know is the opposite angles are congruent. Again, I know this is kind of tough to read maybe, but bear with me. The fourth characteristic of a parallelogram or property, diagonals, I misspelled that, it's okay. Diagonals bisect each other. And the fifth property is that consecutive angles are supplementary. Okay, so we have those different ideas there. So parallelogram, opposite sides parallel, opposite sides congruent, consecutive angles supplementary, opposite angles congruent, diagonals bisect each other. Now, underneath the umbrella of parallelogram, we have 2 special types of parallelograms we discussed. The first one was a rectangle. Okay, and a rectangle has a lot of properties, okay, but there's only 3 here because the first thing we're going to say is that it has all properties of parallelogram. Okay, I know I ran out of room there. So again, rectangle, number 1, all properties of a parallelogram. Number 2, what makes it a rectangle? 4 right angles. And then the only other unique thing about a rectangle, okay, that differentiates it from a parallelogram, is that the diagonals are congruent. Okay, so rectangle, you're a parallelogram with 4 right angles, and that means that your diagonals have to be congruent. The second special type of parallelogram we discussed was a rhombus. Okay, and again, we're still going to... First property, still same deal, okay? All properties of a parallelogram. Now there are 3 unique things about a rhombus that makes it different than just any old parallelogram. The first is that your diagonals are perpendicular. Okay, diagonals are perpendicular. Second unique thing, diagonals, and I'm going to run out of room here, I know I am, bisect, and I'm just going to say this, opposite angles. Okay, so diagonals bisect opposite angles, and then the fourth property of a rhombus that makes it unique is 4 congruent sides. Okay, 4 congruent sides, or all sides are congruent. We probably should have said that first because that's what makes something a rhombus. You are a rhombus if you have 4 congruent sides. Okay, so anyway, you're a rhombus. You have all 5 characteristics of a parallelogram. Your diagonals are perpendicular, your diagonals bisect the opposite angles, and you have 4 congruent sides. And if I take all of these properties of a rectangle and a rhombus and combine them into one shape, we would call that shape a square. And so what we're going to say about a square is, and I'm not going to write this all out, but we're going to say, number 1, all properties of a parallelogram. Number 2, all properties of a rectangle. And number 3, all properties of a rhombus. So you look at all of these, And all of those combine to give you the properties of a square. Okay, so you'll notice a square has a ton of properties. Namely, it's got, looking at this, looks like it's got about 10 properties. So there's a lot of information here. You got to take the time to differentiate between the different shapes and properties and so on and so forth. Okay. After we looked at parallelograms and special types of parallelograms, then we transferred into this idea of a figure having one set of parallel sides. And if something's got one set of parallel sides, by definition, that means it has to be a trapezoid. Okay, so properties of a trapezoid, there's really not a whole lot here, but the first thing we can say is one set of parallel sides. Okay, and then the other properties we're going to talk about really aren't necessarily properties as much as they are just terminology that we have to be familiar with. So one thing that we need to know is parallel sides. Those are our bases. Okay, and then the non-parallel sides are called legs. And really that's as much as we're going to talk about when it comes to a regular trapezoid. Okay, not a whole lot of unique stuff going on there. Now, when it comes to if I really want you to work with trapezoids, generally speaking, I'm going to have you look at isosceles trapezoids. Okay, and remember, isosceles trapezoid is a trapezoid. Okay, so reason one, all characteristics of a trapezoid, namely parallel sides, one set of parallel sides, the bases. Another thing that makes it unique, there's three things. Okay, the first is, and really number two that we're going to have here is legs are congruent. Okay, legs are congruent. Another unique thing about isosceles trapezoid is base angles congruent. Remember, base angles of a trapezoid, there's two sets. And then the last thing is that your diagonals are congruent. Okay, so again, isosceles trapezoid, your trapezoid, your legs are congruent, your base angles are congruent, and your diagonals are also congruent. And the last shape that we talked about, which really it doesn't have any parallel sides, but still has some unique characteristics, is a kite. So number one, again, there's not enough room for me to write all this out. I apologize for not having enough room here. But number one, two sets of congruent consecutive sides. Let me rephrase that. Two sets of consecutive congruent sides. In other words, these two sides are congruent and those two are congruent. They're not congruent to each other though. Okay. Number two, one set of opposite angles are congruent. Okay, so in a kite, you have one set of opposite angles congruent. What else do we know about a kite? We know that diagonals bisect. Diagonals are perpendicular. And the last thing I know about a kite is that one diagonal bisects the other. And if you're in my regular geo classes, you're not going to have to necessarily know that, but in my honors class, we did talk about that briefly. So you should be prepared for that. So reason 4, or property number 4, one diagonal bisects the other. Okay, so again, just a quick review of all the properties, a lot of information. We're going to spend the next few minutes here looking at some examples of applying these properties. So example 1, if I say, okay, what type of quadrilateral has opposite sides being congruent? Okay, well, there's a ton of options there. Okay, if my opposite sides are congruent, then I could potentially be a parallelogram, or I could be a rectangle. Okay, again, all we know is opposite sides are congruent. We don't know anything more than that. Opposite sides congruent, you are a parallelogram, but you could be a rectangle. Okay, it could be a rectangle. If we know that all sides are congruent, then really, again, we have two options. If we know all sides are congruent, you have to at least be a rhombus. We know that for sure. We could go one step further, and you could potentially be a square, though. Okay, so if I tell you that all sides are congruent, and I say all possibilities, you'd have to say could be a rhombus, or it could be a square. We don't know for certain if it's a square, but it could be. So it says quadrilateral JKLM has both pairs of opposite angles congruent. What type of quadrilaterals meet this condition? Well, the most general type of quadrilateral in which opposite angles are congruent is a parallelogram. Okay? Once you know that you're a parallelogram, okay, well, then we have a bunch of things that meet that condition. You might be a rhombus. right? Opposite angles in a rhombus are congruent. You could be a rectangle. It doesn't say that all my angles aren't right. So in a rectangle, your opposite angles are still congruent. And finally, you could also potentially be a square. Okay, we don't have enough information to nail down exactly which one. Okay, so at the very least, we know you're a parallelogram. Have to be a parallelogram. Could be a rhombus, could be a rectangle, could be a square. Okay, so it says what types of quadrilaterals meet this condition. All of those meet that condition. Okay. Relying on marked information alone, give the most specific name for each quadrilateral. All right, so if I look at this first one, it says give the most specific name. Now, not all options, the most specific. All I know about this figure is that all four sides are congruent. Okay? So what does that mean it has to be? It's got to be a rhombus. Could be a square, but we don't know. It's got to be a rhombus. I look at part B. 8 and 8 are congruent. 7 and 7 are congruent. We only have one shape that meets that criteria. This guy's got to be a kite. Okay, no other options. And again, I know I'm going quickly, but this is just getting your feet wet a little bit with these types of questions. Okay, it says, is enough information given in the diagram to show that quadrilateral FGHJ is an isosceles trapezoid? Well, here's the deal. You know what this missing angle is. We have the ability to find it. It's got to be 78 degrees. Okay, how do we know that? Well, first of all, excuse me, if this is 102 and that's 102 and that's 78, I know that the angles inside of a quadrilateral have to add up to 360. So if I do all of this math and I add these three up, subtract from 360, I get 78. And so now I think it makes sense then that we look here, and I'm not really going to worry so much about these steps as much as I am going to worry about just explaining this because I'm already going a little bit longer on this video than I wanted to. So again, 78 and 78 are congruent, 102 and 102 are congruent. Since your base angles are congruent, that makes this thing an isosceles trapezoid. Okay, you'll notice 78 and 102 add up to 180, so that makes these lines parallel. And since your base angles are congruent, this guy's got to be isosceles. So again, I know that's a very brief, quick explanation, but that's really the long and the short of it. Is just the lines are parallel, so it's a trapezoid. Base angles are congruent, has to be isosceles. All right, example 5 says, is enough information given in the diagram to show that the quadrilateral is a rectangle? Okay, and initially you might be saying, well, no, there's only 3 right angles. Again, it goes back to the idea that we know the angles in a quadrilateral add up to 360, and so I could do some simple arithmetic here and find out that that's got to be a right angle. And so the answer to this question is yes, you have 4 right angles. Okay, and that's really the long and the short of it, not anything too tricky there. Look at example 6, parts A, B, and C. Work through those on your own. Identify the type of quadrilateral and then bring that to class tomorrow, and we will start first thing with any questions on those.